I'll just wait another 30 seconds and then we'll get started. All right, let's get going here. Hello everyone, and welcome to the webinar to learn more about the Samsung technology. My name is Ashish. I am a senior engineer here at Samsung Electronics America, and I'm responsible for the enterprise Wi-Fi product within the Samsung Wireless Enterprise Group. I have worked with some of you in the past, or you've heard me speak on the phone about various Samsung products. And then for those of you who have not met me or haven't heard me, well, today is your lucky day. You get to hear me talk about this technology for a good 45 minutes. I do intend to keep the webinar short so that we can focus more on the Q&A towards the end. That way I can give you some time to digest not only your food but all the information that you will be provided here, and hopefully it'll be good information. Before we get started, a couple of housekeeping items. Like any other webinar, all the participants here are going to be muted. You are going to be able to submit your questions on the questions bar, and we will get to it towards the end of the webinar. Terrell Boyer with our SE team is also helping me out, so thank you, Terrell, for that. And we'll try and answer as many questions as possible. Now, if there's a lot more interest in learning more about our products and signing up as one of our STEP partners, please send us an email on sales@v-operations.com. The email address is right there. The webinar is going to be recorded, and we're going to send it out to the partner network after it's done. As always, we appreciate your feedback. Any feedback is good feedback. We can tailor our presentations for the next webinar. So, all right, now that that's out of the way, let's move on to the agenda for today. Okay, so this is what I intend to cover. Before we talk or get into or deep dive into the AirMove technology, it's important for us to understand the different pieces of the puzzle within the Samsung Wireless Enterprise ecosystem. These are the pieces that make the technology happen. So I'm going to spend some time going through a high-level overview, a kind of a bird's eye view of the different product portfolios that we here at the Wireless Enterprise Group sell. Once we have done that, then we look at some of the challenges with Wi-Fi roaming, legacy Wi-Fi handover, particularly as it pertains to real-time communications like voice and video. And then once we've described the problem statement, I will start talking about the AirMove technology and how it addresses some of these challenges, how it alleviates some of these challenges. For those of you who are more technically inclined, you'd be happy to see some message flows. We've introduced a couple of extra messages in the regular 802.11 flow, so you'll be more than happy to see that. So we can go down to that level. And once we've talked the talk, we will walk the walk. So we'll show you a demonstration, a video demonstration of a regular legacy handover, and then an AirMove assisted handover. I'm sorry, I was going to say hangover, but then that's a topic for another webinar, I guess. And then from there, we will look at the VoIP application, which is basically one of our mobility applications that serves as your desktop extension or a desk phone extension on your mobile phone. And once we've done that, then we will try and answer as many questions as possible. All right, so let's move to the next slide here. Okay, so this is our Samsung Wireless Enterprise ecosystem. Oh, I think I need to go back. There you go. So this is our Samsung Wireless Enterprise ecosystem. On the left, you can see our legacy communications platform. For those of you who have been associated with the Wireless Enterprise team, we used to be formerly Business Communication Systems, where we've been selling our legacy office lineup of phone systems to our existing channel base. The office phone system is a hybrid telephony system which supports both digital analog as well as IP-based interfaces. It does proprietary IP for IP phones, and it also supports remote IP phones. It is perfectly well suited for small medium businesses. So the scale is up to 512 users or endpoints. It does particularly well in these kind of scenarios. That's something that our channel base has been selling for more than a decade. From there, we transition over to more enterprise grade voice communications platform, or a unified communications platform, if you will, which is completely IP based. And that's our Samsung Communication Manager Express, or EE, which is basically a software application which runs on a commercial off-the-shelf Dell server. Because it's IP, the way to interface to any sort of an analog interface is through, or a digital PRI interface. You need some sort of a media gateway, and we offer those solutions also. The gateway also serves as a survivability gateway. So in case of a remote branch office solution, the survivability gateway, a host will register all the devices in case you lose access to the corporate location. And then these devices, these endpoints will be able to make extension calls, and they'll be even able to make outbound calls if you have a backup PRI or an FXO for 911 calling. In some cases, you can even receive inbound calls, depending upon how the system is set up. The SCM platform also allows for redundancy, so there is active standby as well as active. Again, the major difference is the fact that it is SIP based and the scalability, so it can scale up to 3,000 end users versus the Office server lineup can only scale up to 512. The SCME also allows for you to connect your standard SIP phones. So there are enterprises that use different models of conference phones. You should be able to hook up that conference phone and set it up as an endpoint on the SCME. It has an embedded voicemail and a light ACD functionality also, and you can set up conferencing as well. That's our SCME. And then we recently launched into the market the SCM Compact, which is basically the same thing as SCME in terms of feature functionality, but it also has a lighter gateway. Some of the lighter gateway interfaces are on board the SCM Compact, and it also has a lightweight PC functionality. And we can get you all the information once you send us the kind of information that you need. But the scalability for C or SCM Compact is around 500 users. From there, we have our endpoints. As you can see, we have the wireless desktop phones, which is the SMT 5343 series. That also supports video and HD voice. It basically rides over Wi-Fi, so having a solid, a robust wireless LAN solution is extremely important here. But the use case for this is many. There could be locations where it's of historical significance, and pulling in cable in such locations is difficult. These phones can be hooked up using a regular power adapter, and they connect up to your Wi-Fi, and you can basically have mobility now with this kind of phone. So there's a lot of flexibility here. Warehouses is a good example. Some historical churches is a good example where these are used currently. We also have obviously our wired desk phones. They are available in different flavors. From there, we move on to the foundation for wireless infrastructure, which is our wireless LAN product. That, if you're not aware, Samsung is in the wireless LAN space, in the enterprise Wi-Fi space, and we've launched our product into the US market for more than 2.5 years. We've developed our references and channel base in these 2.5 years. The wireless LAN product portfolio includes different flavors of access points, which include your legacy ABGN access point, and then the latest and greatest AC Wave 2 access point, which support multi-user MIMO and 4x4 capability and all that good stuff. We are about to launch our IoT access point, which along with the 2.4 and 5 gigahertz radio also supports additional sensors like low energy Bluetooth beacon, as well as Zigbee and Z-Wave. So that kind of fits very well into the entire Samsung ecosystem, where almost all Samsung products that we are envisioning will be connecting in some way, shape or form to the internet by the year 2020. And so our division, we consider ourselves as a glue that will connect all these different devices together. It is a controller based, but the controller architecture is very flexible. You can either have a controller on-prem, or if you're a managed service provider who likes to provide hosted services, you can deploy this in your cloud and manage it for your customers. The architecture allows for traffic to be back to the controller, or you can locally offload the traffic on the customer premises. We also have our WLAN manager, which is basically your central management system, which provides a single pane of glass. So if you are in an environment like a higher ed where you have multiple controllers and thousands of these access points, you have one central location where you can manage these, look at historical statistics, configure the controllers, look at alarms, and all that good stuff. If you want to learn more about the WEM, please check out the webinar that my colleague Terrell Boyer did last week. He provided quite a lot of information in that webinar that will be pretty helpful. As I said, the wireless LAN to us serves as the foundation for many of these applications. It was designed with voice in mind. Obviously, we have a lot of voice background, as you can see, both in the enterprise space as well as in the carrier space. We are under the umbrella of carrier networks, and all this background is important before we move into the technology for tech talk for AirMove, because we've leveraged quite a lot of our experience from the LTE side. So on the carrier networks, we are currently working with Verizon in terms of providing the femtocells, the 4G LTE based femtocells, and that's we are wearing the same umbrella. From there, we have the mobility applications that basically run on your mobile phone, and that they serve as your desk phone extension, and allows for a remote worker to basically carry an extension with him wherever he is at. So if you're a remote employee, the application allows for you to use your phone system to make outbound calls, and then you can have your, you can carry your own device and have your cellular number, as well as you have this application which basically uses your native dialer to call out, and the customer or the end user doesn't even realize that whether the call is coming from your cellular number or whether it's coming from your extension number. You can do extension to extension calling, you can do HD voice calling, and it has some cool features there. Now obviously we have the communications platform, we have the wireless LAN foundation, and we have these mobility pieces. There has to be some unique capabilities that we offer, and we do. So our controller has a proprietary interface with our SCM system, and with that interface we are able to do some cool things like fixed mobile convergence. So let me give you a scenario. You are on a conference call on your wireless desk phone on your 5343, and it's 6 o'clock and you have to go, you have to go pick up your kid, or you have to just leave, but you still want to stay on the conference call. You can just hit a button which will transfer that call onto your VoIP desk phone seamlessly without even anybody realizing that you've moved, or you can even tap the phone if it supports NFC, and you can transfer the call that way onto your mobile phone. And now you're basically mobile with your conference call without even anybody noticing. And now you walk from one access point to the other, seamlessly handing over the traffic. And as soon as you are about to exit the building, the wireless LAN infrastructure controller recognizes that you are now associated with an access point which has been strategically placed at the exit areas, so that as soon as you connect to that, you're going to exit the building. So over that proprietary interface, the controller notifies the SCM that this particular device or extension is going to move out and that it needs to be transferred over to cellular phone. So the SCME will then act as a SIP third-party call controller and transfer the call over to cellular, and you move out of the building and the call is automatically transferred seamlessly. So those are some of the things that we are able to do. Now the AirMove technology is in the area where we are actually roaming seamlessly from when we are on a voice call and we're moving from one access point to the other. So I just wanted to give you this background about the ecosystem before we actually deep dive into the technology itself. So now that's covered. Let's look at some of the challenges that we have with legacy handover. So let's see if I can. Hey, Tel, can you move to the next slide?
Should be
okay, there you go.
Now.
Yeah, I see it. Thank you. So these are some of the challenges with Wi-Fi roaming, and again, you have to keep this in mind that this is, this is more pertinent for real-time voice communications or video communication, real-time traffic. So the biggest challenge is, as we all know, Wi-Fi roaming is, completely dependent on the Wi-Fi client. Unlike cellular or macrocellular infrastructure, where the network makes a decision for you to roam from one base station to the other, so that you do a seamless handover. In case of Wi-Fi, you are pretty much dependent on the Wi-Fi device to make that decision for you, and that basically the Wi-Fi device that you have certain thresholds that are preset, and you don't have any control over changing those thresholds. Those include things like the scanning trigger as to when to trigger the scan, and I'll talk a little bit more detail about it. Roaming delta and roaming triggers and all those things. Now there are apps available in the marketplace. If you are one of those who want to actually go in and see, there are apps available in the marketplace where you can go and see what these triggers are. But these are at the device driver level, and you to make any changes to these require that you work with the mobile team. The second bullet there talks about active scanning, and it says active scanning causes delay in handover. So before we get into the details of this, let's understand how the roaming actually works. So as I said, these devices have set thresholds. So most of the devices that are available today have a threshold of, let's say, a neg 70 dB, and as soon as that threshold value is hit, the device starts what is called as the active scanning process. So I'm a device and I'm connected to an access point and I hit neg 70 dB. At that point, I will start scanning the environment, the RF space, and start sending what is called as a probe request message on all the different Wi-Fi channels. So if I'm on 5 gigahertz, I'm going to start sending the probe request broadcast message on different channels, and then wait for these access points to respond back to me so that I can basically make a decision about which access point is best for me to hand over to. Well, this process takes time because now I have to send a probe request message, wait for this probe response, which is now completely dependent upon the fact that you're looking at contention mechanisms within Wi-Fi itself. So once the probe response message comes in, I look at the RSSI value from the probe response message, and then I look at all these values and then make a decision as to which access point makes best sense for me to actually move over to. Well, what happens in these delays is that you are kind of now delaying sending packets over to your existing serving access point, and that causes a decreased data throughput. Well, if you're on a voice call, that's not a good thing. That's going to take an impact on the video call, which is basically very reliant on, very sensitive to these delays, latency and jitter. So that's something that causes an issue. The second issue is that, let's say you've kind of picked up a particular access point to hand over to. Well, there is still a challenge as to when you hand over to this access point, when it starts, when it considers the start time of the handover. So there's a possibility that you may actually start losing some data there, and that can also happen. Another challenge is that when the device makes the decision to hand over, it does not look at the load, or what kind of traffic that access point has, what kind of what kind of number of VoIP calls it may have. So let's say I'm in an environment which is very voice over Wi-Fi heavy, and I may jump to an access point which is already handling 30 calls, and that's a lot of calls. And so now I have made a decision to move to the access point purely based on the RSSI values that I look at, and now I'm in a situation where the voice quality might not be good because the AP is handling a lot of load. So these are some of the challenges. This is the problem statement. So when we look at the AirMove, we're trying to kind of fix some of these challenges. Now, there are technologies out there which is, which helps alleviate some of these. So if you look at so moving on to the next slide. Terrell, can you?
Should be updated now.
It's taking a while, so sorry about that. It's still not updated here for me, so.
Okay, stand by 1 second.
Recorded right now. We will be updating it and out to the distribution list. So, Terrell, any luck with changing the slide?
Not yet. Stand by 1 second.
So, talking about, let me talk a little bit more enterprise portfolio. We do obviously, handle voice very well. That's one of the claim for, that's our claim to fame. We, that doesn't necessarily mean that it cannot be independently deployed. Obviously, it can be independently deployed. It is a carrier gate solution that we are kind of bringing into the enterprise space. You can, we have models of access point that can essentially do outdoor coverage. We have outdoor APs that don't need any sort of enclosures, if you will. They're IP67 certified. You can essentially deploy it in RV parks, or you can deploy it in like outdoor malls and those kind of scenarios. We have outdoor APs that mesh very well together. And the APs themselves have a feature which is called controlled voice optimization, where the AP recognizes if a voice call is going on, depending upon the codec, and we are voice aware, and then we can change the contention mechanisms, on top of the fact that there is, the WMM standard, which is specified, which is a standard that we support. We are talking about contention mechanisms that are above and beyond these standards. So, all right. So, Terrell, I do see some activity. Can we move on to slide number 5?
Yeah, on my screen it is showing slide 5.
Yeah, it's just not updating. I think we have a lot of people online, so. All right, so there you go. So I do see it now. So as you can see, some of the so let's talk now. Let's talk about the AirMove technology in general. Some of the high-level points. Obviously, it is Samsung proprietary. It is patented by Samsung Engineering. It leverages existing LTE handover mechanisms. That's why I wanted to give you the background about the carrier networks. It only works on supported Samsung devices. It is not supported on Android, on iOS. Apologies. It does require Samsung WLAN infrastructure for it to work, and it does network controlled handover. So instead of you relying on the Wi-Fi device, the network is kind of making the decision for the Wi-Fi device on supported devices. And it is basically making the decision based on the commands that the controller is sending the device. Also, it does require an application component like VoIP to be installed on the supported device. Remember, I did talk about some of the scanning triggers, the roaming triggers, the roaming delta, all those parameters we can change using this application, because with Samsung mobile team, we worked with the Samsung mobile team to actually go into the device driver level and actually make changes to these some of these threshold values. So it's important to understand that you need that complete Samsung ecosystem for this AirMove technology to work. Now, now the question that keeps coming is, do we actually need the phone system for it to work? Well, currently we've released a VoIP application, and the VoIP application obviously works with the phone system, but product management is looking into a separate application that you can just download on supported Samsung mobile phones, which does not rely on the Samsung Communication Manager. So it will be basically between the application and the controller. So that's how that goes. So if you can move on to the next slide, hopefully it can transition quickly here. So. All right, let me see if I can start answering some of the questions in the meantime. Traffic, so it doesn't have to be on a particular AP group. It can be a remote AP group, but we do expect that the traffic tunnel back to the controller. So now another thing which is cool about this whole ecosystem is that the WEM platform actually shows you voice quality monitoring statistics. So if you've seen the demo last week from Terrell, there is a section there which kind of shows you in detail what kind of calls are going on, what's the voice quality, and it goes into the details. We have embedded the VQM engine on WEM, and we kind of display all those statistics very neatly on the WEM platform. So, all right, so slide number 6, Terrell.
Yeah, give me 1 second. Ashish, I'm going to try to switch network connections real quick.
Okay. Well, in the meantime, I can talk about what I was going to show. So the AirMove, what we are going to get into now is the call flow. So let me set this up for you guys. The call flow itself will show a device, a station, which is connected to an existing access point, which we'll be calling that the AP serving or serving access point. And it's going to basically, it has two neighbors. It has your target AP as well as it's your neighbor access point. So, the controller, which is listed by APC, is going to look at all that information and instruct the station to make the decision. So that's what we're going to look at. So, Daryl, it's part 2.
Sure.
Yeah. So the slide before this. Okay, awesome. So as I said, you have a station connected to an existing access point, which we are calling serving access point. It has two neighbors, AP neighbor 1 and AP neighbor 2, and then obviously there's a controller element to it. The station is already connected. Now we've introduced a couple of new messages here. As you can see, these are the NCHO setup request and the setup response. This is an action field and it's vendor specific. So what ends up happening is the setup request and setup response, these are again borrowed from LTE. There's an informational element. So if you go to the LTE based call flows, you would see these messages there. And so that's where we keep on saying that, hey, we've leveraged our technology from LTE. Well, this is where the rubber meets the road. So what ends up happening is you have a device with a VoIP application. The VoIP application sends a setup request to the serving access point, which then forwards it out to the controller. Now the controller looks at this setup request and it realizes that the device is requesting that it will do what is called as controlled scanning. If you remember, I was talking about active scanning a couple of slides back. Active scanning meaning the need for the device to kind of send this probe request to all these different channels. So when you say controlled scanning, you're kind of relying on the controller to come back and tell you what channels I need to send the probe request message to. So the controller receives this setup request, informational element, turns around, sends a response. Now as part of the response, the controller sends to the station a list of items. It sends the controller the information about its neighbors, what channel they are on, and it tells the station, you need to be sending probe request messages only to these neighboring access points on these particular channels. And so that's established. Now, if you go on to the next slide. Okay, perfect. Part number 3. Okay. Now, as soon as that happens, the controller also sends the neighboring access points a command saying that, as soon as you receive the probe request message from this particular station ID using the MAC address, send me a status report. I want you to send me a report which indicates to me what the station RSSI is and what your RSSI and all these values, so that I can calculate behind the scenes which, based on this RF environment, which is the best access point for the AP to transition to. So what happens now is scan trigger happens. So it's at next. So the station is moving away from the serving access point. It hits that threshold value, let's say next 70 dB, and it starts sending the probe request message to the APs that the controller has instructed the station to do. So the controller sends the probe request message, and as soon as it sends it, the APs send back a scan report to the controller. The controller looks at this report and says, hey, the two APs that are neighboring have sent me this report, and it seems like the AP1, which is listed as the target AP, seems to be the best AP to kind of transition to, because it not only does it have best RSSI values, but it also, looking at the background, I'm running some algorithms and also looking at the load of this particular access point. I'm also looking at number of calls that this access point already has, and the best decision at this point is to send it to this AP target. So I turn around and as a controller, and I send what is called as you can see, this gap wrap HOC command, which is handover command, informational element. And again, we borrowed that from the LTE messaging. So lingo is very LTE specific. So the action frame goes to the station, and station receives this HOC or handover command informational element which instructs it to just not look anymore and go ahead and connect to the target access point. Well, it does that same procedure. It goes in, authenticates to the target access point, and the call the call continues without any glitches. So what you've done, if you go back to those challenges, what we've done is we've reduced this whole delays that are caused by the active scanning by doing controlled scanning. We have not lost the decreased data throughput that I mentioned, that we've reduced by more than 2x amount. So you're not basically suffering your voice call while you're connected to your serving access point. And then we've also taken care of the fact that we are actually now looking at the call admission control parameters from an access point before we make a decision for handover. So we've addressed those three. So that's how the mechanism works. Now there's one more challenge to take care of, and that is, if you remember, the data loss mechanism. So when it hands over to another target access point, there is a little bit of a data loss, and you're kind of preventing that in the next slide. So if we move on to the next slide, which by a mechanism called buffered forwarding. So what happens here is the station, as you can see, starts this process of handing over, and then the AP is instructed to buffer the data till this handover is complete. Once that handover is complete, the serving AP sends all that information back to the controller over a secure backup channel, and it also sends the controller the end mark as to where this particular data ends. Once the controller receives that, and once the station is handed over to the target, all that information is sent over, and then there's no data loss in that particular case. So that's how we are able to prevent the data loss. So as you can see, we've kind of addressed all the challenges at this point with this technology. So, I mean, that's, and that works fairly well. So in the next slide, we are now going to look at a demonstration of a regular roam versus a, AirMove assisted roam, if you will, when you're on a voice call. So let me set this up for you. What you're going to see now, as you can see on the screen, there's an SCM administrator screen, and if you look closely, there are roaming triggers, roaming delta, and all these values that we are pushing up to the client. So when the VoIP application comes online, it gets its provisioning information from the SCM, and as part of the provisioning, we tell it that, I don't want your roaming triggers to be near next 70, I want it to be like next 60. So I'm being much more aggressive with roaming, and I even change the roaming delta value. So the VoIP takes this information, feeds it to the device driver, and changes these values on the supported Samsung phones. Now a call is made. So on the right side, you will see that a call is made using VoIP. So that's the screen that we have for VoIP. So Tel, can you turn this on? Okay, so he's made a VoIP call, and the call you would see is complete. So we have a green here, and the call is complete, and it also shows you the quality of the call right on the application. And now here on the left side, there is a legacy data roam, and on the right side, you have a roam with VoIP. So what is happening is, if you look on the left side, we have 5 gigahertz turned on, 2.4 gigahertz is turned off. The devices, there's a Samsung channel 48 and channel 44. As soon as, currently I'm connected, if you look on the VoIP side, currently I'm connected on channel 48, and I'm moving away from the access point, and I am reaching the threshold of next 60. As soon as I reach the next 60 threshold here, you would see that the device would have roamed. So I'm at next 61, and you would see that the device will roam any minute now. And so you can see the red sign right there, and it has already moved to channel 44. Versus on the left side, the data only, I'm at next 60, I still stay at 48, which is fine. Versus I have already roamed over to the other access point, and I'm at next 67, I'm still at channel 48, I still haven't made that roam. Next 67 there, next 72, still no roam. And I've already, as you can see, I'm already connected to the other access point. So finally, at next 72, the data device roams to the other channel. So that's how, you can see that it's pretty aggressive and it does fairly well. So you can see the roaming trigger there at next 60 and the roaming delta at 4 and roaming scan periods. So, there's clearly the AirMove assisted roam is much better for voice calling or real-time calling versus your legacy data roam. So, all right, so if we move on to the next slide. Okay, so this is the VoIP application. You can download the VoIP application from the Android Play Store, or it's for SCME. It is also supported on iPhone. So for the on the Apple Store, you should be able to find the Samsung VoIP application. It is licensed as an extension on your SCME. So it does take up one of the licenses. And so this is how the interface looks like. We've made a lot of updates to it, so you might actually see a little bit different. But the whole idea is that you are basically carrying a desk phone extension, right? So you should be able to get all the same features that you get from your desk phone on your mobile phone. So I have the capability to put a person on hold. I can transfer when I put the person on hold. It would be the same music on hold message that they would hear that you would basically get from your desk phone. You can record the call. You can transfer the call to mobile. When it says to mobile, when you hit that button, it'll actually transfer it to your cellular number. You can carry two numbers with you. So there is your regular cell phone number, and then you have your company assigned desk phone extension number. And then when you make this call through VoIP, you can configure on the SCM what number goes out, what caller ID goes out. You can be anywhere in the world. You don't have to be just connected on Wi-Fi. It also works with LTE. Obviously, on the network side, you require an element like session border controller to kind of support that functionality for security purposes. But you have those kind of capabilities where you have a remote employee, or if you're a global workforce, you can hand off these mobile extensions, and they can be anywhere in the world, and they can use the data plan. Or if they're in a hotel somewhere, they can use the hotel Wi-Fi to connect back to your phone system and use the features from the phone system. So, and then another cool thing with this application is that it uses your native dialer. So it doesn't have its own contact list that you have to maintain. You can use the same contacts that you have on your cell phone, and then dial the extension out. You can do extension to extension calling wherever you are at. It provides HD voice. Obviously, you can transfer a call onto your desk phone if it's NFC. That's pretty cool. And then it supports the whole FMC, where you can transfer the call from a Wi-Fi network to the carrier's cellular network when you're out of the Wi-Fi coverage. So, all right, so that's all that I have in terms of my presentation. I'd like to address some of the questions that I've received. So if you give me 1 second, let me just pull up these questions. So I can just pull it out, right? There you go. Okay. Does the AirMove work on other devices like tablets, or does it have to be a Samsung product? That's a very good question. Currently, the AirMove works only on the Samsung mobile devices, supported Samsung mobile devices, and I can tell you some of the other devices that we support. We support the Samsung S3, Jelly Bean or later, so S4. We have the Note series that it supports. So all the latest and greatest cell phones with Samsung we support. We don't support it on tablets. Unfortunately, we are working on a solution for the tablets. Also, the VoIP does not do any video. So it is it's voice centric only today. So that's another feature there. Will AirMove functionality work when VoIP is used on iPhones? Unfortunately, no. As I said, the AirMove will not work when VoIP is used on iPhones because AirMove does require the device driver controls that we have with with the iPhone. We don't have that control. We made those changes on Samsung only. So let me see. There's more questions here. And you can always send more questions out to sales@v-operations.com, and we'll be able to answer those for you. Let's see. Okay, what other voice features are supported on the Samsung APs? As I was mentioning in the middle somewhere, we were talking about controlled voice optimization. The Samsung AP does have the capability to recognize that there's a voice call going on, and that's irrespective of whether you have the VoIP application or not. We are able to recognize the G711 call and able to change the contention mechanisms to provide much better quality to voice calls than your regular background traffic, if you will. So there is mechanisms in place, and that's why we in our sales, we keep on talking about the fact that we are very voice focused on our access point of wireless and infrastructure. Is there IM/presence? For the VoIP application, there is no IM capability, so that's something that we don't support. But on this SCME as well as on Officer, we have partner products that enable some of these capabilities, and there's quite a lot more there. So there is enhanced ACD features, there is enhanced call center features, or features which allow for you to deploy in look at voice quality statistics and whatnot. So any way to bring in voice and status from Microsoft products? So that's a very good question. We are actually working on something for business. Product management is looking into it. R&D is working on software which will kind of use some of the functionality I just talked about for better roaming for Skype for business and stuff. It's not released yet. We are looking into it. We are actually working towards releasing something pretty soon. But the technology is already there. As you can see, that's the cool thing. The VoIP application just relies on the supported Samsung device and the controller. The messaging is between the application and the controller. So we can always develop this application which does not require the SCME and can still provide this AirMove kind of roaming. And that's where, depending upon the market demand, depending upon the justification from product management, we can always look into it. The technology is already there. So, okay. Will you add iOS and other Android products over time? So again, VoIP does work on iOS devices. You still get all your extension calling. You still get all your features. You are only relying on the mobile device at that point for roaming. That's the only thing that changes. But you still get the capability where if we have an environment where it's iOS and they have VoIPs. VoIP, and if they have our WLAN infrastructure, we can recognize that there is a VoIP call that is happening, and we do quite a lot of enhancements for downlink voice traffic, like for instance doing multicast over VoIP. And so those features you still get. I mean, the only thing that you don't get is the AirMove, which is particular to the roaming. So you can rely on things like 802.11r for roaming at that point. But yeah, you won't get the AirMove, but other things are available. So okay, there's a lot of questions related to iPhones. Okay, so I'll wait for another 30 seconds. If you don't have more questions, I'll conclude this webinar. Again, please. If you have more questions, feedback in regards to this webinar, please send them to us or at sales@v-operations.com. We are in active recruiting mode, especially for our wireless LAN product. We are looking to add more partners. You can go through our STEP partner pro. Once you send us an email, someone from our inside sales team will get back to you. They'll walk you through our STEP partner program. And it's a great time to be a Samsung partner. That's all I can say. All right, so looks like there are not any more questions. Okay, there you go. How can I get a demo unit of remote access? If you send us an email at sales@v-operations.com, someone from our inside sales team will reach out. We'll sign you up as a partner. We'll get the NDAs drawn, and then we can send you some demo gear there. We have the capability of shipping out access points that obviously for our partners. There is also some work that is being done towards demo units that you can buy and have installed in your office locations, so you can play with the product and get used to it. All right, so thank you so much. I really appreciate everybody logging in and listening on this webinar. Keep a lookout for emails from Samsung Wireless Enterprise for future webinars. We intend to do this very often to highlight some of our technical capabilities and some of our unique differentiations in the marketplace. Thank you very much. Thanks, Cheryl.